Hi class, and welcome to the SQL 4 lecture. This is going to be, Oracle Chapter 4, Access Chapter 5. I'm going to use MySQL for the demo, but no big deal. There's not really a whole lot of difference in the syntax, and where there is, I'll talk about it. So we're going to be talking about functions. Okay. We're going to be going over strings, counting, a couple of other little odds and ends here, but anyways, they all have to do with functions. And now if you program, you know darn well what a function is. A function, or even if you've taken college algebra or beyond, a function can take an input, or, well, one or more inputs and return a single value, right? A function only returns one single value. Okay, you can have function return data structures which are made up of more than one value, but anyways, a function takes multiple inputs and returns one output, basically. Okay. All right, so I guess we'll go ahead and get started here without any further ado. And at this point, you should have already seen the PowerPoint, read the PowerPoint, or read the PowerPoint and watched the Illuminate session on it. If you haven't, please stop and go ahead and do that, and then come back to me. Well, if I can get in here, there we go. Okay. So now MySQL has a couple of built-in databases here, Skila and World, and then I had this from some stuff I was doing for last lecture. These are kind of like the Northwinds database that you get with the Microsoft databases with MySQL and I think even Access. But I was kind of poking around here, and something that I found interesting was I looked. We have an actor table here, and I said, all right, actors. And then I was disappointed because I didn't see any famous names. They kind of hint at it, that I guess for fear of lawsuits they don't actually name any real names. They say Penelope Guinness instead of like Penelope Cruz. They say Nick instead of Mark Wahlberg, and so forth. But yeah, Scarlett Johansson. We have Matthew Johansson, since when does she become a dude? I don't know. But we have Joe Swank instead of Hillary. Same there. I don't know. Zero Cage instead of Nicholas. I like Nick Cage. He's not a zero. He's cool with me. Okay, and Uma Wood instead of Uma Thurman. But anyways, I guess we'll go ahead and use that. It caught my attention. All right. So without further ado, we'll go into the one I guess I've had the most questions about so far this week. Count. Yes, it is a function. Otherwise, I couldn't use it in this manner. Okay. Select blop from actor. Well, blop has to return a value, right? So count does return a single numeric value. There we go. So there are 200 actors in the database. Now, we'll go ahead and do this. Thousand films, because I saw actor and I saw film, and what really caught my attention here was film _ actor. That kind of looks like an M3C thing, right? Where you go ahead and take a table and you make the concatenation of the primary keys of the two to kind of relate them together, so you don't have repeating groups. And look, that's exactly what it is. We have actor ID and we have film ID. So this table serves to relate actor and film. Okay. So yes, M3C really does apply in the real world. You don't just read about it and then forget about it later. Actual professional database developers use this. So we have this film that relates the two, actor and film, to prevent repeating groups. So this is in the name of, for the sake of normalization, so that we don't have all these different anomalies that I talked about, data corruption that we get happening. All right, so this links the two. Okay, so if I have, film returns 1,000. So we have 1,000 films in our database. Okay. Supposedly, we can verify that they're all distinct, that they're all unique, but we'll assume that that's the case. And we have 200 from actors. So let's say I want to query, I want to know how many actors have appeared in films in our database. I can just do it like that, right? Select count from actor film, right? Wrong. I just got a Cartesian product. I did not join the tables. I didn't specify any constraint. I didn't specify a clause on that. So that's why I've got 1,000 times 200 is 200,000 rows. I've got a perfect Cartesian product. Now if I wanted to get the 2, how would I do that? Well, let's see. I could look and see if maybe actor, let's see here, what do we do? You know, in Access you would just do a desk on the data, and you can actually do that in MySQL. Okay, and you can see the table makeup there, and just like in Oracle. Or you know, if you're using Access, you can look at the table design like so. Same thing. So we have actor ID, first name, last update. Okay, I don't see any foreign keys that may be from film, because if I expand film, yeah, there's no foreign key that appears in actor. And likewise, actor is the primary key. Actor ID is the primary key in actor, and I don't see that in film. Well, darn, how am I going to do that? Well, don't forget we have this intermediary table here. Intermediate, intermediary, whatever. So we'll go ahead and sort of jump through that table since it contains both of them. Since I can't do a direct equality, I can't do an equijoin directly between actor and film, I'll do it through film actor. And I'll just show you the count that way, and we'll kind of reinforce these concepts we've learned. Oh, by the way, another thing. Count is really important and it's really useful. I think we had an exercise in Oracle last week, especially if you're an Oracle student. You know, if you misstep and you do a count when you're joining tables, if you do a count and you have a quasi-Cartesian product, you're going to get rows scrolling and scrolling and scrolling and scrolling past your terminal screen, and it really ruins your night because it ruins your output. Okay? So that's where count is useful. You know, if I forgot to put any constraints there, I'm going to get one result that says 200,000. You can always kind of peek at your data that way by using count. All right. Now, whereas if I just did that, well, it's picky about the parentheses there. So if I just did that, well, that's okay. I can have 200,000 results here and not really care about it. But if I had Oracle, I'd be unhappy right now because I'd see data scrolling and scrolling. It would look like the matrix, you know, on my little command line window there. So that's where that's one of the utilities of count anyways. But anyways, I wanted to get the count. I wanted to see how many actors had actually appeared in films in our database. So we're going to go through that intermediary table. It's really case insensitive. It doesn't care. But I'm just OCD like that. Okay. So this way, when I jump through this intermediary table, where actor ID equals film.actor ID, and where film ID equals film actor dot, oops, that should be film ID. Okay. All right, so I got my quality there. So basically, that's going to allow me to jump through that table and line up where the particular actors appear in the particular films. Let's see, what have I got here? Looks like we've got a parsing error. Well, I don't see that that's a problem. I'll go ahead and try to execute it and see if it. Oh, yeah, there we go. It disappeared. It was just a little leftover from parsing. The parser's pretty good, but you know, stuff does happen. All right, so we have 5,462 instances of actors appearing in films in our database. That's a lot better than 200,000, did we say, or something like that. It seems a lot more real. Seems a lot more feasible. Okay. And I guess we'll go ahead and create our own tables and do some examples that way. I don't really want to mess too much with this database. I might like to come back to it later. And I have made a backup of it. So I'll create a new table. I'll base it loosely on actor here. Call it like silly actor, or goofy actor, or whatever. And they'll have names, and I'll make those their primary keys. And I'll say they have an address, right? The 400 was good. Okay. And I'll insert some data in here. Our actor's going to be what? Bob. I like that name, Bob. Simple. And I'll do this for a reason. So I got Bob lives at 1313 Elm Street. He lives on Nightmare on Elm Street or something. Or is that Friday 13th? I think I was Nightmare on Elm Street, right? 1313 Elm. And then we also have Anna, and she doesn't have an address. Okay, by the way, MySQL will allow me to batch these like this. Okay? If you're doing Oracle, don't try it that way. But MySQL, SQL Server, etc. will let you do it. Oh, whoops, I pressed it twice. So let me see. Did it insert 4 rows? Probably. Well, actually, it probably stopped where that error occurred, so probably not. So we want to see our data first. Yep, Anna has no address and Bob lives at 1313 Elm. Okay. And I'll expect 2 results here, right? Yeah, there we go. So now what if I change this a little bit? What about if I say select count of the name attribute instead of count all? Now remember, a function has input and a function gives an output. Okay? Function can have, these are called parameters. Okay? What goes between the parentheses there, parameters, and you separate them by commas. But we only have one in this case. You know, count only takes 1 input and gives 1 output. All right? But it does return a value, of course, which is the number, and it takes an input parameter. You know, if I do asterisk, it's going to count everything as a whole. All right? So basically the way that works is if any of the rows have a value in it, it returns true. Okay? Which we should see 2 here, right? There we go. But based on that criteria and what I just said, what if we have count address? Let's look back at it. Okay, my address is null for Anna. Bob has 1313 Elm. So what do you think is going to happen? 1. Count does not count nulls. Okay, if the value doesn't appear there, it's not going to count it. It doesn't increment that counter. Okay, so you only have 1 there because of the null value. All right. Let's add another record for the heck of it. He lives at 1313 Elm too. He's Bob's roommate. Yeah, he was inserted. Joe and Bob living together. Joe Bob. Isn't that good old boy name? Joe Bob. Now, another function. Actually, it's not really a function. Keyword. Check this out. Okay, so I have 2 addresses in the database, and they're the same, right? So what do you think my distinct keyword does? It's going to count the number of, supposedly, right, the number of unique addresses. So let's find out what we got here. Oh, oops, sorry. There we go. I had it backwards. Yeah, so there we go. Sorry, distinct count, count distinct. Sometimes it's late here, folks, so bear with me. All right, so count distinct addresses. It returned 1. You know why? Because it counts the number of distinct entries. It's all unique, and then it's all unique again, and discard that unique entry, that superfluous, that excess entry. Okay, so this brings up a good point here too. If you're using access, count distinct will not work. Okay, access is funny. Bill Gates didn't want count distinct, so he decided to be different, right? He has his wild side. He's different. He's a different cat. No, not really, but I think he's about as nerdy as they come. There's a way around this. There you go. Oops, not select. Select distinct address from select actor. So that's the workaround in MySQL. Select count of everything from, and then you'll select your distinct whatever from your table. So in this case, this would count the number of distinct addresses that are unique addresses we have in silly actor in Access. Now MySQL is going to gripe at me. It doesn't like it. Every derived table must have its own alias. I know I've come across this before. And I think Oracle will gripe at me too, although actually I'm not sure that I've ever tried it, but I don't imagine that would work. So hey, try it. Why not? Experimentation is good, right? Except for stuff you shouldn't experiment with. I can't tell you that. All right. Okay, so we got distinct count. Oh yeah, there's some other aggregate functions here. Yeah, that's what I'll use. So I made up a table here. Let me see if I have any values in it. I can't remember. Oh, actor amount paid. So there we go. All right. I'll go ahead and drop it. And I'll recreate it. Oops. All right, so I'm going to go ahead and create a table called actor amount paid. I thought it'd be fun. We'll go ahead and we'll take actor ID, which I'm not really going to link it to the actor ID that we see over here in the actor table, and then we have an amount. That's a floating point value that they make. Okay, so we'll it's just a fictitious table that we can manipulate a little bit here. All right, So I've got two, you know, we'll create one more. All right, seems kind of paltry for actor salary, but you know, maybe they're, I don't know, just stage actors and not big-time movie actors. All right, so I'm creating a table, actor amount paid. Okay, we'll take the actor ID, which is an integer, and then the amount they made. All right, so actor number 1 is made 20,000, 2, 10,000, 3, and 5,000, and that should take. Yep, it did. All right. Now, we have, like I said, we have some more aggregate functions. They'll take several values and return a single. All right, and they're actually pretty self-documenting here, pretty self-explanatory. What do you think sum does? All right, what do you think that's going to do? You guessed it. It's going to return the sum, or you know, all of the amounts added together. What did we say? 20,000, 10,000, and 5,000. So we should get about 35,000 back, right? There we go. All right. AVG. No, not the antivirus program. Average, right? So, gosh, for that one we got what? 35,000. Is the sum divided by the total number of entries is going to be 3, so that'll be 11,666.66666, etc. Yeah, there we go. 11666.66666. So that's the average amount that the actors got paid. It is. You know, you can do the addition there and the division if you like. Okay. We also have, well, let's go ahead and show you min. Right, my minimum is 5,000. And what do you think max is going to be? I think we had 3 entries that were 5,000, 10,000, and 20,000. So max would be 20, right? Okay. And you know, these aren't, you can combine these. There we go. So yeah, there you go. Max, min, average, and sum all together. Okay, so that's how those work. There we go. This will be interesting. Yep. All right. Took it. Oops. So there we go. So now I've got 4 rows. Actually, I have a repeat there. If it were really a primary key, it would have barked at me and told me I can't violate the primary key constraint. But anyway, excuse me. Anyways, I had these 4 entries. One of them's null. We still have my original 3. All right. Now, what do you think is going to happen if I do this? All right. Doesn't count nulls. But what if I want to give that some kind of default value? Like, let's say if we don't have a salary there, we need to count it as 0 because they were working pro bono. Okay. And I think that's right. Is that right? Yes. Holy cow, it jumped up. So what I did here, actually let me change it back to what I said I would originally tell you. I just thought it would be cool to see a big amount. There we go. All right, so what I did here, I did what I just described. I said, okay, if that entry is null, we'll treat it as a 0 instead of just ignoring it. You know, when I ignored that, the average, you know, it's an aggregate function. It ignores the nulls. It just took the existing values that we had in there and it took the average of those three. But when I did this, I told it, hey, if the value is null, go ahead and treat it as a 0. If the value of amount is null, treat it as 0. So select average of all of them with a 0 for any nulls from actor amount paid. All right, and that's what you're actually looking for is NVL. It's going to be null value anyways in Oracle. Oh, and this is an NZ in Access. I don't think it's going to accept that. Let's see. No, I don't even think it'll. I don't think it'll take NVL. No. No, so it's a little bit particular. That's one of those things that is, you know, indeed implementation specific, but it's the same thing. If null, NVL for Oracle, NZ for Access. All right. So let me take a look at my data again. All right, so now the string matching part, the fun part. There are a whole heck of a lot of expressions. You know, if you're looking in the Oracle book, just for example, this is what I have on my side on page. If you flip back to 152, all the fun starts. You got substring, in string, right pad, left trim, right trim, length, like, upper, lower. So you have all kinds of stuff you can try out there. You know, don't be afraid to go back to this and reference it. Yes, you'll see it on the homework. No, it won't be sprung on you, all the ins and outs and every little detail on a test or exam, but you should know that these functions exist. If you forget the exact implementation, not a problem. You can always go back to and refer your documentation. There are some things I will expect you to know by heart. This is not one of them. So I'll just go ahead and go over the important parts here. We'll go ahead and do a little bit of basic string matching anyways. Now, what do we say we have? Oh, there it is, Anna and Bob. So, there we go. And this follows Oracle syntax, I believe. Let's see here. Let me make sure. Yeah. So, the percentage is called a wildcard. Okay. Now, what a wildcard does, it matches any and all characters. Okay. Since we don't have anything before or after the percent, if we don't have anything after this percentage marks, anything that starts with AN will match. So we'll get Anna, okay, and well, here I'll prove it. Anishka. Then I'll go back here and say select all from, gosh, what was it, silly actor. Where, name, like, don't forget the like keyword, okay? You can have equals in there, but then you're going to need a match, so use like. So now this should match according to what I told you. Oops, name. Or a name like. AN wildcard. So this should match both Anna and Anishka. It'll match anything that begins with AN since we don't have anything after the percentage. Okay? Start row. What do I have here? Let's see. Oh. All right. So I'll go ahead and get rid of that row. And I'll insert it the right way. What is the right way? Geez, I've already forgotten. There we go. So name followed by address. I was thinking actor ID or something, I guess. I don't know. I was thinking one of our previous tables. Just look at 555 main, nice generic address. Okay, so now we'll try this again. Alright, so here's our data. We have Anishka and we have Anna. We have Bob and we have Joe. So if I do this, since that percent is a wildcard, it'll match anything after this N. So all I care about is AN. You know, if you've ever done networking, you know what a wildcard is. You know, wildcard is the 255 or at least the 1 bit in binary. You know, now that we don't have class full addresses anymore, strictly speaking, we can, you know, anytime we see a 1 in the subnet mask, that's going to be your wildcard. It basically means it doesn't matter what it is, whether it's a 1 or a 0. Or excuse me, if you see a 0, I got it backwards actually. If you see a 0, then basically what we're saying is, you know, no matter whether it's a 1 or a 0, it matches. Go ahead and you know, allow communication. And then when you see a 1, you say this part has to match. So when we see AN here, it's basically the same. That part has to match. When we see a percentage, just like a 0 in a subnet mask, you know, it doesn't matter what it is. And also this percentage here, you know, it's kind of unique in that it will allow any number of values. So we could have, you know, in a cornucopia there, and it would match. You know, it doesn't matter whether it's 1 or whether it's 100 characters, or 1,000 or 1,000,000 characters for that matter. Okay, and let's go ahead and see. Yeah, Anishka and Anna, they both matched. Okay, now what about if we do that? Okay, the percentage is a single generic, or actually it's a single wildcard. Okay, or rather, gosh, let me rephrase that. It's a simple wildcard. Now my underscore is a single character wildcard. Okay, it'll match numbers and characters, and there are implementations. I think there's a wildcard that will just match letters, and then one that will just match numeric. But anyways, the underscore will match anything. So in this case, since each underscore here is a wildcard for a single character, that should match Anna. A-N-I-S-H-K-A. That should match Anishka. There we go. And this should match not a darn thing. There we go. Yeah. So percent. Actually, I'll give you another example. What do we have here? Aha, what do you think this is? All right. Okay, so what do you think this is going to match? We're name like percent NA. Well, okay, the percent is any number of characters, and it doesn't matter what kind of characters, and then we have NA at the end, so I'm thinking that's going to match anything that ends in NA. It doesn't matter what comes before it. So Anna would match, right? Yes, sir. Now here's a trick for you. Here's a good one. How about that? Oops. And if I go too fast for you, feel free to pause after I ask a question and before I actually go into it and show the answer. Okay, and so that way you can test yourself. So what's that going to match? Think about it for a minute. If I look at it from left to right, any string of characters followed by 2 N's followed by any string of characters. Okay, so basically as long as we have the pattern N somewhere, anywhere in this string, we're going to return a match, right? So it should match Anna, right? And you know those two names, Anna and Bob, I just kind of realized I chose them first, and I really wasn't thinking about it, but just like a little aside here, a little nerd moment. They're palindromes. A palindrome is a word that's the same from, you know, the beginning to the end, and the end to the beginning. A-N-N-A, A-N-N-A, B-O-B, B-O-B. If you haven't done programming, if you haven't done recursion, you maybe haven't seen that, but if you have, you may know what it is. Just a little pocket protector moment there for you. And let's see. Yep, matches Anna. Okay. What about this? Any single character followed by an N followed by the percent. What do you think? Anna, that's right, because we could have an A there, and we can have anything here, so that could be another A. Okay? And I can do this, I'll still get Anna. And I can do this, and I'll still get Anna. Alright, just remember that if I do this, I won't get Anna, because it is definitely looking for two characters here. Okay. I have to scale it back to 1 to have it match the A in the beginning and the A in the end. All right. And just to be fair, just not to be, you know, to not be sexist, we'll do little fun combinations. There we go. So, you know, since we end in OB, we're obviously going to match Bob. If we want, we can string match to the middle. Oh, hey, I got a Joe too. Yeah, because Joe has an O somewhere in his name. Well, then if I do this, I'll still match both of them, right? Because any character followed by O followed by any character. Yep. And you can play with little combinations like this. It's easy enough. It's easy enough concept, but sometimes, you know, multiple examples will hammer it home, and just you'll learn by osmosis if nothing else. Okay. And here's one for you. How about that? How about that? Yeah. Any string of characters, followed by any string of characters, and an A. Now, how about this? What do you think that's going to do? String of characters is optional. So I could have this, and it would still match. Okay. Oh, also the percentage sign, I should mention, the percentage sign is the wild card for MySQL and for Oracle, but in Access, I believe we're talking about the asterisk. Okay. And I believe that's a single. Well, maybe it's not, but the underscore is the single in all three. In Oracle, Access, and MySQL, the underscore is the single wild card, the single character wild card there. So I guess that's going to wrap it up. You know, I'm not going to cover these the string matching functions too in depth. You have homework on it, and you do have the reference here to go back to. It's easy enough. It should be easy enough to complete the homework, but if you do have problems, please discussion board, email, or call. And that is going to be a wrap here, so I guess I'll be talking to you soon, if nothing else, at the next lecture. Okay, thanks.